Greetings, and welcome to Train Signal. In this lesson, we're going to be covering subject matter from the primary heading in the Microsoft 70-341 exam entitled Plan, Install, Configure, and Manage Transport. Our main focus for this lesson is the subheading Plan a High Availability Solution for Common Scenarios. Keep in mind that this lesson is about high availability with regard to the transport role. So we're not talking about high availability in terms of the mailbox server as far as databases, database availability groups, and so forth. We are specifically focused on transport, on mail flow, and making sure that there is some redundancy here, and we're going to talk specifically about what's built into Exchange by default. Now this objective may include, but is not limited to, set up redundancy for intra-site scenarios, planning for the transport dumpster, planning for shadow redundancy, and planning for redundant MX records. Keep in mind, when we say planning for the transport dumpster is a term that was used with Exchange 2007 and 2010, but with 2013 there have been enhancements made, and this is now called the safety net. Nevertheless, the exam objectives still use the term transport dumpster in the focus list for the various subjects that you need to hone in on, so we list it here as well. Now let me just say from the get-go that a lot of our discussion for this lesson is going to be more of a discussion of concepts. It's not going to be a lot of demos or a lot of step-by-step implementation, and that's because at this stage in the game, the idea is to understand why certain things are happening and what is built and under the hood in terms of the architecture. You'll see exactly what I'm talking about in just a moment. Okay, so let's get started. Now, the company that we're going to focus in on is called Sporty Kayak. Sporty Kayak is a startup that had in-house Exchange 2013 installed by our company. We initially recommended that they go with a hosted solution using Office 365 considering their size and budget and so forth. They declined that offer. They wanted an in-house solution, and so we set them up with Exchange 2013. We set up a single server with the client access and mailbox server roles installed on the same system. Considering their budget, we did not at that time implement any amount of high availability in terms of redundancy of hardware or redundancy of Exchange services. Now, the problem is the in-house Exchange administrator, he's Exchange 2010 aware, but not incredibly familiar with Exchange 2013. And so we've recommended that he watch some training materials, of course, to get up to speed, but he's concerned about transport availability. And he should be, because there really is no high availability built into this deployment at all. So there are some concerns that he has, and we're going to address these. So our goal is going to be to educate the administrator on what new measures are built into Exchange 2013 for transport availability, and we're also going to explain what planning would be needed in order to increase availability support. So think about it. What would you say to this Exchange administrator? Oftentimes you might just say, well look, you need redundancy, so we need to have multiple servers. And maybe he's aware that with Exchange 2010, especially with regard to transport availability, if you wanted to have redundancy of the hub transport server role, you would just install an additional hub transport server. And that would be pretty much the end of the story. But is it really the end of the story? You see, without truly understanding what's going on behind the scenes, what's actually happening in terms of mail flow, how it's working, things like shadow redundancy, things like the safety net, without really understanding those things, would you honestly be able to say you have a total grasp of what Exchange is really doing? Well, no. And so that's what we need to really map out here. So let's get started by defining a little better what happens on either a single server or between a client access server and a mailbox server in terms of the transport pipeline. Okay, so here's what we see. We see in this case two different servers. That's just to make it easier for you to mentally grasp the difference between the two different sets of services that are available. So we have the client access server and the mailbox server. Now, these server roles can be installed on the same physical box. That would just mean that the services that you see here are all working together on the same box, but we still want to divide them mentally in terms of their roles. So you can see here that the client access server, handles the front-end transport service. On the mailbox server, there are two transport services. There's the transport service, and then there's the mailbox transport service. The mailbox transport service has two different services connected to it, the mailbox transport submission service and the mailbox transport delivery service. Now, before mail goes into the mailbox database on a mailbox server, it has to travel along a lot of different lines and through a variety of different services, as you can see here. All along what's called the transport pipeline, there's the possibility that that mail could be lost, the power could go out, something could happen. And so we look at these different services, and we could imagine mail coming into that client access server and being pushed through to the mailbox transport service and vice versa. You can kind of understand that there's a lot of things happening behind the scenes here. Alright, so let's start up at the top. The front-end transport service. This service runs on all of your client access servers, and it acts as what they call a stateless proxy. So, in other words, what this does is it passes through messages inbound and outbound in terms of SMTP traffic for your Exchange organization. It doesn't queue messages, it doesn't inspect content, it's not meant to be like an edge transport server in any way. Nope, it just communicates with the transport service on the mailbox servers, and it makes sure that mail flows in and out. Now, the transport service, this runs on your mailbox servers, and it's pretty much what we had before with your hub transport services. So, you remember the hub transport server role? If an administrator says, yes, I remember hub transport, I worked with Exchange 2010, okay, so then you can basically tell them that we still have a front-end transport service, but for the most part, your hub transport services have been merged into the mailbox server role. And in the case of the transport service, it handles all of the SMTP mail flow for the organization. It can perform message content inspection and so forth. So the service here works the same way the hub transport server role worked for us before. But it doesn't actually communicate with mailbox databases. In that sense, there's the mailbox transport service that's right below it, also on the mailbox server. Now, this mailbox transport service, basically, it has two separate services that you can see here, the mailbox transport submission service and the mailbox transport delivery service. So what it does is, using remote procedure calls, it will deliver messages and retrieve messages and submit messages basically over SMTP to the transport service and over to other mailbox servers. So these two services under mailbox transport service, they make sense. If you look at the mailbox transport delivery service, imagine mail coming in, going through the transport service, and being handed off to the delivery service, which then uses RPC to put that mail in a mailbox database. By the same token, when end users send emails out, imagine that mail using RPC to go through the mailbox transport submission service and then to be sent out from there either to the transport service on other mailbox servers, so it can actually go directly from the mailbox transport service right out to transport services of other mailbox servers, or it could be sent up to the transport service, and then from there it could be sent in other directions, as far as whether it's going to other mailbox servers, whether it's going out to an external SMTP, to other servers in that sense. So this, in effect, is the new transport pipeline for Exchange. Now, you might say, I love this. Wow, this is really great. I love knowing that there are these services here, and I want to know more about how all of this works. Every little nitty-gritty detail about the transport pipeline. Well, the good news is there are articles that are going to be referred to at the end of this lesson. They really lead you right back to where most of the content and information is on these services at this point, which is TechNet itself. And so if you take the time to read TechNet and dive a little bit deeper than this, then you really can start to enhance your understanding on the inner workings of Exchange. So you might look at learning Exchange from three different perspectives. So there's the typical administrative perspective, where it's more of a, hey, how do I get this to work? What do I need to do? What steps do I need to take? What checkboxes do I need to click? There's that end of the game. Then there's the next level. We're really looking at going deeper than being able to administrate Exchange, but understanding the concepts, understanding the whys behind certain things, and going deeper in terms of how Exchange works. But you can go even deeper than that. Beyond the certification, you can actually go to the master or expert level by studying even more so and looking into even perhaps pursuing the idea of being an Exchange ranger. And so really those folks, they understand Exchange right down to the bare bones architecture of things. So in this case, we're taking it to the next level. We're outlining how Exchange really works. So you may know as an Exchange administrator how to get your servers up and working, how to get your end users to send email in and out of your organization and so forth, but you may not have a good grasp of what's happening really behind the scenes. And so that's where understanding the transport pipeline, understanding the services and what they do, that's where you're really taking your knowledge to a whole nother level and gaining a greater level of depth in terms of your understanding of Exchange. And you'll see that that can be very helpful, especially when things are not working quite the way they should. Okay, and so along those lines, we started this discussion talking about transport high availability. So how does that actually work? What high availability do we have with a single server deployment, or even a deployment like this where let's say we have a client access server and a mailbox server and they're separate from each other? Well, in all honesty, there's no high availability here. In order to have high availability, you need redundancy. And it doesn't just mean having two Exchange servers, but you need redundancy of Exchange server roles. Now again, you may know that. You may know that, hey look, if I want redundancy, I need to have additional Exchange server roles. You may even know how to configure them in the sense that you may be able to set up two mailbox servers and make sure that you have a DAG set up and have passive copies of your active databases. So you may understand the concept of high availability. But there are things that are working behind the scenes that happen automatically if you put the right pieces in place. So let's discuss that. Let's talk about transport high availability and what it does. So ultimately, transport high availability ensures redundant message copies during the delivery process. Now, what do we mean the delivery process? Well, mail comes in again to that front-end transport service. Before it gets there, it's on the line, it comes in through the service, it goes to the transport service itself. The transport service passes it off to the mailbox transport service. You can see how there's a lot of things happening before that mail gets put in a database. And even after it's put in a database, what actually is there to ensure that we have some availability of that data for any period of time? So that's where the transport high availability features that are built in can be very helpful. So now you might be wondering, okay, so great. So what do we have in terms of the front-end transport service? That client access server, what is it doing for us? Well, in all honesty, the client access servers do not have message queues. They accept SMTP connections and they proxy mail that comes in back to the transport service on the mailbox server. And that's where it ends. The client access servers do not provide any transport high availability. They really just are sort of a go-between between that SMTP connection to the outside and your internal organization. Okay, so we don't have to think about anything in that respect as far as what your client access servers do for your transport high availability. Everything is pushed off to the mailbox server role. Now the mailbox server uses both shadow redundancy and the transport dumpster, which is new and improved in 2013 and as mentioned is now called Safety Net, to provide message high availability while that message is in transport. And then even after the message is delivered, there is the safety net to ensure that there's a redundant copy of that message for a period of time. Okay, so shadow redundancy is helpful in terms of providing message high availability while the message is in transport, and then the safety net is something that assists after the message has been delivered. And the two work together actually. So let's talk for a moment first about shadow redundancy. Shadow redundancy was introduced in Exchange 2010, and what this feature does is it ensures messages have redundant copies made and that those copies are not removed from the transport database until it knows that the message has been delivered. So the nice thing about shadow redundancy is in the event this message is lost somehow in transit, the shadow redundancy feature will attempt redelivery using that redundant copy of the message. So how does this work? What's required? How do we plan for this? Well, for starters, it requires multiple Exchange mailbox servers. And that makes sense. You can't have a copy put somewhere else without having somewhere else for that copy to go. So if you have a single Exchange mailbox server and you want to make sure you have shadow redundancy, you're going to need to have at least a second mailbox server. Now you can take these mailbox servers and you can form a database availability group. You can make them members of that availability group, and you can actually create some type of high availability for your active database. At the same time, behind the scenes, there will be shadow redundancy that's now included. You don't have to do anything to set this up. It's automatic. Once you have that secondary mailbox server in the mix, the shadow redundancy solution is actually included. There are a couple of pieces to this, however, that you need to keep in mind. For example, if you have multiple Exchange mailbox servers and they're not part of a DAG, then the other mailbox server must be in the same local Active Directory site. And that's the only way that shadow redundancy is going to work in that case. However, the good news is if you are using a DAG, then the other mailbox servers must be in the same DAG, and they can be local or remote in terms of the Active Directory site. In fact, shadow redundancy actually prefers to use the remote Active Directory site for the shadow copy for redundancy. And that makes sense, really, so it's nice to know that this is done by default. However, again, it's only if they are grouped together in a DAG that it will use the remote Active Directory site. If these are just mailbox servers that are sitting on their own, they're standalone, they're not part of a DAG, well, that's still going to work just fine in terms of shadow redundancy. It will use another server in the same Active Directory site. The primary and the shadow server, they keep in touch through a heartbeat, so this way they know that they're both still alive and working. The goal is to have 2 copies of this message within any transport high availability boundary. Now, what do we mean by a transport high availability boundary? This is a term that when you do some reading in terms of TechNet and you dig a little deeper here, you're going to see this term come up from time to time. So what does Microsoft mean by a transport high availability boundary? Okay, so it's good to note that shadow redundancy works within transport high availability boundaries. It never tracks a message across a boundary. And so in terms of what boundaries exist, a DAG is a reasonable boundary. So any servers within a DAG are part of the same high availability boundary, and that may span multiple Active Directory sites. And as we already mentioned, a mailbox server may be standalone, it may not be part of a DAG, and so in that case, an Active Directory site, a local site for mailbox servers that are not in a DAG, becomes another high availability boundary for transport. And so the nice thing about these boundaries is that they make it so that Exchange only has to worry about its own transport high availability boundary, what's happening in its world. So if it's part of a DAG, that's one thing. If it's not, then it's the Active Directory site that matters. But ultimately, it doesn't have to worry about messages from outside of its own transport high availability boundary. So you can have servers in 2 different sites, still part of the same organization, but if they're not part of the same DAG, then they don't have to worry about making sure they have shadow redundancy for messages for additional sites and servers. They only have to worry about their site or their DAG. And so that makes it a little bit more manageable in terms of keeping track of all of this for Exchange. Ultimately, when a mailbox server receives a message, it worries about its own transport high availability boundary. It makes sure that there's a redundant copy of that message. It doesn't have to worry about where that message is going in terms of if it's going off to another server, that server has to worry about it. It doesn't have to worry about the sending server where it received that message from. It just worries about its own transport high availability boundary. Keep in mind that shadow redundancy is on by default. It can be disabled, and you can configure certain parameters using the set-transport config commandlet. And so that's one you want to take note of, the set-transport config, because this is one that you may use in a production environment. You also never know when it might be included in a test question regarding the Exchange core services. So using this commandlet, and in this case using the shadow redundancy enabled parameter, you want to set it to false. It's true by default. And so you can actually disable shadow redundancy. Why you would want to do that is beyond me, but you do have the ability to disable it. At the same time, you can use the same commandlet set-transport config to reject messages that do not have shadow copies created using the reject message on shadow failure. By default, it's off by default. You can set it to true to turn it on. Now, as we already mentioned, shadow redundancy, it doesn't track messages across transport high availability boundaries. So when it crosses the boundary, that's when shadow redundancy will begin or restart. The other point that we want to mention is that there's a shadow redundancy manager, and that manager actually keeps track of pretty much everything. So it keeps track of things like maintaining the list of primary servers for each shadow message, processing discard notifications, and a whole list of other things. In fact, the list can be found if you research the articles on TechNet that are listed at the end of this discussion. Well, you'll be able to find the information on the Shadow Redundancy Manager and see the list of 7 or 8 bullet points as far as what it does overall. Okay, so let's switch gears a little bit and let's talk about SafetyNet, formerly known as Transport Dumpster. So what this does is it provides message redundancy after the message has been processed. So it's a queue on the mailbox server that's associated with the transport service. The default retention time for those messages is 2 days, so it keeps message copies before they expire and then are deleted until that time. So ultimately, when a user sends a message in Exchange 2013, the mailbox transport service on a mailbox server submits it to the transport service on the local server for processing. The safety net is the queue that stores copies of messages that were successfully processed by the server. So ultimately, when a user sends a message in Exchange 2013, the mailbox server, if there is a second mailbox server or it's part of a DAG with additional mailbox servers, it makes sure that there's a shadow copy, a redundancy of that message before that message gets to the mailbox server's database. So that's great for transport high availability in terms of making sure that even as the message is traveling to the database, there is a copy of it. So in the event of an outage or there's some type of corruption in transit or the message fails to reach the destination in some way, that's okay. The shadow redundancy solution will make sure that it gets resent. But what if it already reaches the mailbox server and goes in the database? So you might say, well, then it's done, we're good to go. But the safety net is there to assist with messages after it's been processed. So there's that little bit of extra assistance when it comes to the safety net. Now you might wonder why. Well, this makes sense when you start thinking about high availability and database availability groups, because what was nice about Transport Dumpster is that in the event the active copy of the database went down, it became corrupted, or the server went down, and the passive copy of the database became the active, the first thing it would do is it would check in with Hub Transport servers and see if there were any messages in the Transport Dumpster that it did not have in the passive copy that's now the active. Because something could happen along the way there. During the failure or the corruption, perhaps messages that came into the Hub Transport service, they did not make it into the active, or maybe they made it into the active database, but those were never copied over to the passive. So somewhere along that transport pipeline and the high availability solution pipeline, you can call it, the messages are sort of lost there. But the nice thing about the Transport Dumpster is that it had a copy of messages for a period of time, and you can configure that. So the same concept applies here, that you have a default 2-day copy of messages that come through, and the transport service, which was formerly known as the Hub Transport Server role, but now, as we mentioned earlier, this transport service, it has a queue that's associated with it that will retain copies for a period of time, and the default is 2 days. So hopefully that makes sense in terms of the reason for the Transport Dumpster, now called SafetyNet, and how this can help in providing high availability, because it makes sure that even if the database availability group does actually provide redundancy, and let's say the active does go down and the passive does take over, it can look to the safety net for assistance. Now, in addition to that, what's also cool is that there is a shadow safety net. And so that's a redundant copy of the primary safety net stored on another mailbox server in the same site to provide further redundancy. So you see we have messages flowing in, we have redundancy of those messages, shadow redundancy, and then when the messages are delivered, we have safety net, but guess what? We have primary safety net, and we have redundancy of the safety net as well, called shadow safety net. So can you start to see how all of this is coming together? Well, not to worry, we're going to show you this in a diagram in a moment, but it's good for you to start putting this all together mentally here. Now, much like shadow redundancy, with the safety net, there is still transport high availability boundaries, primary messages, and then shadowed messages or secondary shadow safety net messages. All of these same concepts apply. So it's not like you have to learn a whole new solution for availability with safety net that's different from shadow redundancy. A lot of the same features apply. As far as 2013 and how safety net enhancements have been made with 2013, well, for one thing, DAGs are not required. So even without a DAG, you can have safety net and you can ensure that messages are retained for a period of time, even after they're delivered. Safety net is redundant, as we mentioned. You have primary and shadow safety nets, and there are no message size restrictions, so you can configure the length of time, but you don't necessarily configure the size restrictions when it comes to 2013. Ultimately, safety net goes into action or message submission if there's an automatic or manual failover or switchover of a database in a DAG, or if you make a lagged database copy active. And so that makes sense in that the safety net now can assist in making sure that those messages are up to date, that anything that might have been lost from the transport pipeline getting into the mailbox database itself or going from the active over to the passive copy, that the safety net has already, and so it makes sure and checks in and makes sure that all those messages are up to date. Now the shadow safety net, that goes into action if the primary safety net is unresponsive for 12 hours. So that shadow safety net, again, is for that redundancy of the safety net itself. So it has that extra little bit of protection that we didn't have before. So that's a nice extra feature in 2013. Now, there are unique considerations with shadow safety net, and so at the end of this lesson, again, there are several TechNet articles that you want to take a look at if you want to learn more about shadow safety net and really any of these features if you want to take them to the next level. It's good to note the set-transport config commandlet is also used with safety net configuration. Some of the parameters that you might want to have in mind are safety net hold time. As we mentioned, the default is 2 days, but you can change that. You can make the time longer. And that's essential if you're using lagged copies, because with lagged copies you want to make sure that the safety net parameter actually matches the lagged copy parameter. So if you have a lagged copy of 2 days, then you're good to go. But if you extend that and it's 3 days lagged, then you want to make sure that your safety net is as long as your lagged copy is. So just something to keep in mind. Some of the other points in terms of high availability that we want to keep in mind include redundant MX records. Now, we all know that when we're setting up Exchange, if we want mail to flow into our organization, we have to configure our external DNS servers to use MX records. And so you might set up your DNS MX record. You know that they're essential if you want mail to flow into your organization, and so you do this and you're good to go. You might take a look at your current MX record or records by doing an MX lookup through MX Toolbox. So you go to mxtoolbox.com, you put in your domain, let's say in our case it was exchange.com, and it would tell us if we have one MX record or if we have multiple MX records and where those MX records are pointing. The value of having redundant MX records is that it allows for greater availability and flexibility. So you can set this up using priorities in order to keep MX records organized within DNS. So you might set up, let's say, a backup mail server in your organization at a secondary site. Maybe you have that server that has less bandwidth available to it, and so it's just your backup. Or maybe you have a server hosted by a third party that provides backup MX services. Whatever the case, ultimately by having the redundancy and by having a secondary MX record, you're making it so that mail can continue to flow in even if there's a problem with your existing Exchange server solution, your environment in some way along the lines, some type of hardware issue, some type of network issue. So we mentioned that it provides for greater availability and flexibility. Some of the things to keep in mind here is that you might have multiple paths into your organization, and so you can use the multiple MX records to provide load balancing. You can do this by setting them up with the same preference set, the same priority levels, and so in that sense it will load balance and round robin. So if you have, let's say, edge transport servers on the outside perimeter, if you have multiple edge transport servers, you can set up the various MX records to point to different ones, and so it will round robin and load balance the solution. At the same time, that provides for a backup in case the primary solution is unavailable. Let's say the primary edge transport is unavailable, it will jump to the second one. You can actually adjust the priority levels so that if you want mail to flow through one edge or through one path, whether it's a hosted solution. Let's say you're using a hosted solution that's providing archiving or providing antivirus or anti-spam or whatever. So then it can go through that solution first and then into your organization. So perhaps you have redundant MX records for those solutions as well. So you can see there's a lot of different ways to handle your redundant MX records. Number one, you should have redundant records. You should have redundant solutions. So you should have multiple ways for mail to get into your organization. You may use them from a round robin perspective, or you may use them to ensure for different priority levels so that there's redundancy, and so there's an opportunity if one is unavailable, there's that backup MX record. You can also consider using the backup MX record as another mail server in your organization or at a secondary site that has less bandwidth available, or some other solution, whether it's a third party that provides backup MX services. So there are many reasons to have redundant MX records. In some cases, you're looking at providing for greater load balancing or greater availability, but ultimately it's something that's essential for transport availability. All right, so now let's go back to our scenario again. So we've explained all of these different things to the Exchange administrator. He's starting to see a better picture in terms of how Exchange 2013 is different from Exchange 2010, how the roles are different, there are different services in play, how they work together, some of the enhancements in terms of shadow redundancy and the new transport dumpster with safety net. Okay, so now that we have all of that clarified for the administrator, what would be our recommendation for this environment in terms of providing for greater levels of transport availability? Well, for one thing, we know that they're a small organization. They have a single location. We would recommend that they consider multiple Exchange servers that would allow for higher availability of mailbox servers and transport. Now, we might also recommend certain third-party solutions, perhaps a way for them to increase their availability in that sense as far as having these solutions available to them. But for the in-house Exchange environment, in this case, we need to have at least 2 mailbox servers. We would recommend that they be DAG members, so we would create the whole database availability group, add the 2 servers to the DAG, and then we would make sure that there was a redundancy in terms of a passive copy of the active database. So that's great as far as the high availability for the database itself, but in terms of the transport redundancy, because we've added another mailbox server, automatically that would provide the transport redundancy that we need. The fact that they're members of a DAG, that would mean that they're all part of the same transport boundary, but in all honesty, even if we didn't create a DAG, the mailbox servers in the same local Active Directory site would still be part of the same transport boundary. So either way it would have worked out fine, but being that we do have that now second server, we can make the 2 servers part of a DAG and at least create some kind of server redundancy, some type of data redundancy in terms of active and passive. Now, in addition, we're going to recommend multiple CAS servers. This is to provide a higher availability of the CAS role. We're going to include a hardware load balancer solution. In fact, we would recommend multiple load balancers, but being that it's an expensive solution that we're presenting, and again, they are a startup, they may not make everything redundant in their environment, and that's okay. We understand that. So we're going to recommend a Kemp load balancer in this case because they're very cost effective and they have a good reputation in the industry. We're looking at this and we're looking at other ways we can provide for redundancy in terms of hardware, network redundancy. Really everything needs to be mapped out. If we can't provide complete availability, we need to at least know what we are going to do in the event of an outage of sorts, in the event of some type of failure. So that's important. At the same time, we're going to ensure that there are multiple MX records with alternate access IPs and priority levels. This will ensure redundancy. At this stage in the game, they don't necessarily need to round robin their access. They don't have multiple access points, and so we're not necessarily worried about that, but we are going to provide multiple MX records with different priority levels. That will ensure redundancy as well. Alright, so we want you to have an understanding as to how this all works. And so we've talked about a lot of different terms and things, but it's good to see it. And it's hard to see something that's actually not physical. It's not something you can literally pick up and touch. So by using this diagram, it hopefully will help to explain what's happening as we go through the process of mail coming into your mailbox server. So if we look at this, imagine mail has come into your mailbox server. The mailbox server, there's two of them, so there's a redundancy there, and the two servers are set up in a DAG arrangement, just like the arrangement we're proposing for our fictitious companies here. So looking at this diagram, this is pretty much what we're recommending to the company here as far as the scenario. We're looking at setting up a separate mailbox server and putting them together under a DAG so that they're part of the same transport high availability boundary. Again, even if you don't put them together in a DAG, that's not going to matter in terms of being part of the same boundary because they're part of the same local Active Directory site in this case. So, but we're going to put them together in a DAG. We have these two servers. Okay, so mail comes into the mailbox server, and this could be coming from a third-party SMTP server. It could be coming from the client access server, maybe from another Exchange 2013 server that's sending mail over. So this mail could be coming from a lot of different places. In this case, it's coming from an internet SMTP server, and it's being proxied through the client access server that we have, and so it's hitting that mailbox server. So the first thing that happens here is the mailbox server that receives that mail, it opens up a new SMTP session over to our secondary mailbox server. It opens up that session and it says, okay, we have to make a shadow copy of the message. And so the secondary server makes that shadow copy of the message. So the first mailbox server has the primary copy of the message, the primary message. The secondary server has the shadow message. So what happens next? Well, the next part of the process is that back on the first server, we look at step number 3. We know that the transport service is going to process the message. It's going to pass it through to make sure that it gets to that local mailbox database. So it pushes it from transport service to mailbox transport service, and then it gets into the mailbox database. Once the message is delivered, a copy of that message is kept in the primary safety net, which is a queue on the transport service, and that is kept for 2 days. Now, at the same time, there's a discard status message that's waiting for the secondary mailbox server, so that when you see in step 4, when it checks in, it receives that discard status of that message. And so the next part of the process is that the secondary mailbox will remove that shadow message from the shadow queue and actually will put it in the shadow safety net. So can you see how all of this is working? Just to go through it again, when the mail message comes in, the transport service opens up an SMTP session, lets it know, hey, we have to have a shadow copy of this message made on this other mailbox server. At the same time, the message goes through to the mailbox transport service, to the mailbox database, and then once it's safe there, the primary safety net has a copy of it, and the discard message is given over to the transport service on the secondary mailbox server, and when that occurs, then a copy of the message is put into the shadow safety net for the same period of time. And again, all of this is built right into Exchange 2013. So having an understanding of this, knowing how all of this works, really it helps to enhance our appreciation for what Exchange does for us behind the scenes. At the same time, as an administrator, it's also good for us to know that we have this kind of redundancy. But if we don't have that secondary mailbox server, if we haven't given thought to making sure we have redundancy of those services and solutions, well, then look at all that we're missing. So when it's time to present the reasons for the added cost, it's good to note that these features are part of that reason. So it's not just that you want a second mailbox server so you can have redundancy of the mailbox database, although that alone is a good enough reason, but all of these other features that are built right in, these are additional reasons for having that redundancy. In fact, if you could go one step further, and if you could create another server off-site, perhaps in a secondary data center, that would be even better, because then you not only have remote redundancy, perhaps also as part of this DAG, having a third member there, but then you could also ensure that in this case, if they were all three part of a DAG, then the shadow redundancy and the shadow safety net and so forth would also be off-site. So in the event of any major problem, you then have the site resiliency there in terms of your transport availability. So we focus mostly on intra-site availability, but in that case you would be making sure that you have the transport process or pipeline made more resilient and more available by making sure that you have an off-site server. Alright, and so as promised throughout the lesson, we're going to mention a few TechNet articles that would be worth researching. So if you want to learn more about mail flow, you can check out this article here. If you want to learn more about transport high availability, if you want to learn more about shadow redundancy, and if you want to learn more about the safety net. You'll note that all of these articles are pretty much connected to each other, so if you go to one, you'll be able to find the links for the others as well. At this stage in the game, Exchange 2013 is quite new, so there aren't that many additional articles either from the Exchange team or even from outside bloggers, MVPs, and so forth that explain these features any better than TechNet itself. So we recommend at this point that you go to TechNet, you learn as much as you can about these various features. There's a lot of reading involved. Really, there's only so much we can put in a lesson, in a video lesson, on the transport availability solutions and features. So hopefully at this point you have a broader understanding of things, but if you want to dig a little bit deeper and to really increase your knowledge of these various solutions, we recommend at this point that you go to TechNet in order to do that. So we hope you found this informative. We'd like to thank you for viewing, and I'll see you in the next lesson.